Hello everyone, Becca here. I thought I'd just make this quick video going through the assembly of the EleksDraw. I found that there's not actually many online resources about this assembly, and the instructions themselves are also a little bit difficult to follow, and there's a few things that they don't mention that I feel like they should mention. So I'm just making this video. If you run into any problems assembling your EleksDraw, hopefully this video will be able to help you out, and also hopefully this video will give you any tips before you start building your EleksDraw, just to make the process a little bit easier for you. So getting started, this is where I sourced my EleksDraw from. I think it's pretty much the only place you can get it from, Banggood. So this is the listing. If I scroll down, there's some specifications. Wiring instructions. There's an assembly instruction guide on the EleksDraw forum, which we can click through there. That's open in the next tab, so we'll go through that just now. We have an official software download, EleksCam. I'll talk about that later in the video. That's available there. And there's also a laser engraving module, which you can buy through here, I think. There's a bit more information. There's some reference images here, and we'll actually we'll use these reference images to kind of just outline how everything's built and help along with the assembly process, because a lot of the images in the next tab are going to be very close up. It's good to kind of get further out view as well. So yeah, that's about it. So for those that don't know, of course, a plotter is a kind of a drawing machine that works on 2 axes, and these motors, as what combined with specific instructions sent to the computer, will allow a pen to draw any shape whatsoever. There's a servo at the bottom here that kind of dictates whether the pen is drawing or not by lifting this carriage up and down. Now this carriage over here, in order to get it to go down, a bit of weight might need to be applied to it, so you might want to slot some weights into there just to kind of make it go down, because there's a bit of friction between the bearings and the rail. But yeah, other than that, I think we'll get started. So the assembly process kind of, it has a few steps. The first thing that we're going to assemble is this little thing over here, and what that is it's a belt feed for behind the pen holder. After we assemble that, we'll assemble these housings on the left and right, and as well as the motors, and we'll screw that all together, and then from there we attach the bars between them, and then we create this little rail system, the shorter one. Then we sandwich them all together in this little assembly, bolt the little odds and ends on, so that we'll bolt this pen holder on, and then we do all the wiring, and then we're pretty much done from there. There's a bit of problems that you're going to encounter, you might encounter along the way. A couple of mine were, this rail piece was a bit different than the images suggested for me, so what they shipped to me was different to what they were showing, so I had to work around that. And then also for me, one of these cables was too short, so I had to do a solution to that. So I'll show you what I did for those. The first thing I'd suggest though, before you start anything, is to really get a ruler. And so get a ruler that has millimeter measurements. And the reason I say that is because with all these photos, it's gonna mention in the bottom right what screws, what nuts, what standoffs you'll need to use. So this M3 by 30 millimeters, what that means is it's a 3 millimeter diameter. So that's the M3 part, and then the by 30 millimeters is it's 30 millimeters long. And having a ruler on you will allow you to quickly identify the screw, because otherwise there are other screws of different lengths, of different diameters, mostly just different lengths though, that may confuse you. So you'll be using the wrong screws, and then you might use the screw that's too long or a screw that's too short, and then not really know why you're missing screws later in the build, or other problems, I guess. So yeah, besides that, let's get started. The first thing that you want to do before you start anything, they don't show it in these pictures, is each of these acrylic pieces, on one of the sides, since it's acrylic, when acrylic is laser cut, there's a protective film on one of the sides. and that particular film, sometimes it's brown, so it's just clearly obvious there's a film on there, and you just peel it off on all the pieces. Sometimes it's not obvious, so on mine it wasn't actually obvious, and it was actually a white film that was on there, but it had text on there as well, so like kind of Chinese characters, and I thought initially that was, for some reason I thought it was like a printing defect or whatever. I kind of just dealt with it, that they're using scrap pieces to send me and my kit, but in reality it was actually a protective film. So what you want to do is kind of use a razor blade or whatever, get underneath that film, peel it off on all the pieces, and then I don't think it really matters in the end, but I guess in terms of aesthetics it would be good. My EleksDraw has some of the protective film just left on it because I didn't take it off beforehand, and I didn't feel like reassembling the whole machine. So I don't think like in terms of functionality, it doesn't really matter, but in terms of aesthetics, you'd probably want to do that. Second thing is I'm just going to be going through the kind of instruction manual and filling in the gaps. I'm not going to reassemble my EleksDraw because I do not have the patience for that. But hopefully this video can be useful nevertheless. Okay, let's get started. So the first thing we're doing is we're assembling this little piece over here, and that is the piece behind the pen holder. So that's pretty straightforward. There's this rubber shim that comes with. Next we're going to construct this piece, which is the pen assembly. Now this was where I first started running into issues, because these are the pictures that they show. This is a forum post I made, by the way. It's available on the EleksDraw forum if you want to kind of read it in full. But so this is what they have shown, and then this is what I've got. So you notice that there's a screw hole here that's missing, another one here down here that's missing, and then this rod over here is actually longer than the one they give me, and then the one they show. So I didn't know what to do here, but in reality all you need to do is, it's pretty much the same process. So here they have two M3 by 10 screws that they shove in there, in those two holes. What I did was I just bolted this onto here and put the screws through those holes. It lined up well. The only difference really is that these standoffs, what they do in this kind of diagram is they act as end points for the rail, so this the carriage can't slip off the rail. For me, that's just what I need to be careful of now. So yeah, and yeah, I just need to deal with that. Another problem would be that the pen carriage in my build will be resting on the servo pretty much all the time. So that might lead to problems down the line. I might see if I can fix that, but just something I have to deal with. Yeah, and I'll just make sure that it doesn't slip off the end. So if this is the problem that you've kind of arrived at, where they've given you these different pieces, that's how you solve it. Just bolt it on anyway, and make sure it doesn't slip off. Fun. Okay. So the next bit is once we've bolted that on, we bolt the servo on, screw that in. These are some really thin screws and thin nuts, so just it's like M2, so that's 2 millimeters thick. So yeah, these are pretty annoying to get on, but once you do, it's all good. Then we bolt on the pen carriage. Of course, we want to get the orientation right. There's a thumb screw that comes with it. Mine didn't actually come with the thumb screw, it just came with this very thin screw over here, just a normal screw. So it was a bit of a pain actually, because trying to screw that in with your fingers is a bit, you don't get much traction, but that's what they gave me. Yeah, no thumb screw for me. But yeah, now when we get to the motors, we have this gear that we want to screw onto it. So the way that the shaft is the way that the shaft is shaped is it's cylindrical except for one side, and one side is just flattened. And the benefit of that is that the screw that we're screwing here kind of can lock onto that flattened side. Now we need to be careful, I guess, when assembling these to make sure that this screw actually is oriented correctly so that it does latch onto the flattened side, because if it latches onto the cylindrical side, it's not going to get much traction and might lead to slipping and spoiled prints. Another thing we need to account for is that this shaft is actually only flattened for 3/4 of the way, so the final 3/4. This initial bit is cylindrical, so we don't want to bolt onto the cylindrical bit. We want to make sure the gear is far enough away to latch onto the flattened side. And besides, we don't want to make the gear too close to the housing, otherwise then we'll encounter some issues with friction between the housing and the gear. Perfect. Next thing we do, so we do that for both motors. Next thing we do is we bolt those into these pieces over here, pretty self-explanatory. Just make sure that this connector is facing the right way. Then we bolt these columns, these standoffs into, actually, yeah, I think the columns, not standoffs, so yeah, sorry about that. But yeah, so we bolt those into this piece over here. And then what we're doing at the, yeah, so, and then we slip in these pieces into this aluminium housing, and what this will do is kind of provide the body for the part that we're building. So we bolt that in, and then we do the same to the other side. Now we just want to make sure that these notches all line up, so that they're all on the same side, and it's as shown, as it's the same as what's shown in the diagram. We also want to make sure that these are all aligned. It shows here them screwing it in all the way. I'd recommend maybe just leaving a tiny bit of slack and then only screwing it in all the way once we've got everything kind of assembled, because that will help with a bit with alignment, but it's up to you really. Yeah, make sure that you're just doing things on the right side. Rubber feet go onto the bottom, the same side with this slot and the square slot over here. And we just screw it in, and yeah, so that's pretty much that bit done. We just repeat the same for the other one. Now, of course, this piece over here won't have these standoffs on, because these standoffs are for the computer, and we only need one computer for the plotter, so it's only on one side. Perfect. So we've pretty much finished these bodies over here. Next thing we're going to do is work on the central carriage. Now, these come with two pieces. The slots in this piece are aligned this way, but in the other piece they're aligned across like that, I guess lengthways. So we just need to be a bit cautious that we're using the correct one. These screws, these shorter columns, these standoff screws screw into there, and then we screw the pulleys onto there. Now these pulleys don't go in all, these screws for the pulleys don't go in all the way, so don't worry about that. But I guess this is where we want to make sure we get our column lengths right, because we want to use the longer ones for these ones. Perfect. And now what we want to do is we want to slip these linear bearings onto the rods. Now the rods we need to make sure are clean. Initially they'll probably come through a bit dirty / grimy. So in order to just make sure that everything works nicely, just get out a dust cloth and wipe those down. Yeah, I haven't put any lubricants on mine, but do as you wish, I guess. I'm just a bit afraid to use lubricants and mess up the bearings. So once we kind of get that done, we want to screw the rods into each end of the housings through those holes. So we just use some M4x14 screws, and then so we do that to both sides. So this is with the longer rods actually, so we want to make sure we use the longer rods for that, and then for this kind of shorter axis across here we want to use the shorter rods. So we just screw it into this end piece over here and screw it into this pulley that we first assembled. Now we just need to make sure that this slot up here and this pulley are on the same side. Yeah, just make sure they're on the same side so that the belt can fit through flat. Perfect. Next, what we want to do is we want to bring this kind of pulley carriage that we've assembled and slide it underneath and then lift it up using a box underneath these pulleys. These linear bearings, sorry. So yeah, we lift that up, and then what we do next is we get the shorter carriage and then we place that on top perpendicular. Just make sure that it's facing the right way, I guess. so that you're following the instructions. And then we want to, from there, we want to feed the belt through. Now I know this belt looks taut. I initially I fed it through, kind of got the general shape. I didn't tighten it at this point. I think tightening it at this point would be a bit difficult, especially because the top carriage isn't actually attached to this. There's nothing keeping it attached to these bearings, so if you try to tighten it there, it's just going to pull, and I don't think it would work. But yeah, so I just left that a bit slack. Then I fixed this top on, and then I tightened it. So when we're fixing this top on, what we want to do is we want to make sure that these bolts are sitting flush with the bearing, with the spacers. We do not want to over tighten these. And so once it's flush, you may feel like it can go tighter, but if we actually screw it in tighter, what will happen is whenever the carriage moves, you'll hear this grinding sound, and we don't want that. So just back off a bit on all of these screws. Yeah, so once we've done that, we kind of tighten our belt, just make sure that all the slack's taken up, but it's not too tight. The main thing, it should still be able to be plugged. The main thing here is just making sure there's no slipping on the bearings. Tightening it's enough for that, for no slipping to occur. But yeah, next what we do is we bolt this onto the pen assembly, we bolt the pen assembly onto this piece of acrylic. And now what we have is pretty much the whole assembly, except for the wiring and except for this bottom piece over here. Now this, at the moment, these two housings are only connected by the rails. So this bottom piece of aluminium provides a good base and some extra support. Now when we're installing this, we want to flip the whole machine over, but we want to make sure that this pen assembly is lying off the edge of the table, because of course this pen assembly is a bit higher, a bit taller than the motors, and otherwise it'll just won't sit flat and might damage a piece. So yeah, we flip everything over, resting the machine on the two motors and making sure the pen assembly is dangling off the edge. From there, we slot the bar in. It should be a pretty snug fit, so it's pretty well measured out in that sense. And then we put the two M5x10s, the four M5x10s, two on each side, into there and tighten those up. And then we flip it back over, and now we can get onto the wiring. So on this side without the standoffs, we want to use the longer cable, because that longer cable will come out here and snake through the bottom of this aluminium shaft. So we plug it in. We want to make sure that we use the right connector, because this cable, it doesn't have the same connector on both sides. So we plug it into there, snake it through, and then pop it out this side. We plug the short connector into the stop motor up here. Then what we do is we plug these into the computer and then mount it. Now my computer actually, I had a bit of a problem with my plotter, being that this cable, the short cable up here was actually too short. So it wasn't able to snake around and plug in. So I had to solve that issue. I'll go through that momentarily. But I guess for those that aren't experiencing this issue, we just want to make sure that these are plugged into the correct ports. So from the diagram, it's a bit difficult to see, but the longer cable plugs into here, and the shorter cable plugs into the left-hand side. I'm pretty sure that is correct. Maybe take it with a grain of salt, because my axes are flipped. I don't know whether I'm pretty sure that's a bug within the software though. So yeah, just plug it in like this, short cable into the left, longer cable into this piece over here. Okay, so and then we bolt the clear acrylic on top of that. Now my problem being that this cable was too short. One way that you might want to fix that is by rotating this motor 90 degrees around. So what you do is you'd kind of, so this won't be plugged in, you kind of unbolt these, flip it over, take it out, flip it over. Of course, we need to loosen this belt as well. So we loosen the belt, unscrew these, flip it over, take the motor off, rotate it, put it back on, bolt these back on, and then test the cable length. And if it's good, then kind of retighten the belt. But yeah, so for me, that didn't work either. So what I actually had to do was I flipped the whole computer around. So I flipped it 180 degrees, and I rotated this motor to the right instead. So this short cable kind of snakes around and plugs into here. This longer cable was actually long enough to come up and plug into there. And then I also had to do a couple other adjustments, which I'll go through just now. After I've kind of explained the baseline, I guess, if you aren't experiencing any problems. So we have these two cable runners that come with. They're slightly different. This one, there's one with kind of a small hole on the right angle part and a bigger hole on the right angle part. So the smaller hole one goes to pin assembly. We just bolt it in as shown in the picture. And one with the bigger hole that goes to the housing with the computer. And that just bolts in like in the picture. So after we've done that, we just run the cable through, snake it through all the way, and plug it into the, so it comes out the cable here, back behind the computer and plugs in. So that would be the last picture, but I'll show you, see if I can find a photo here of it, just to show you guys. Maybe, well, I mean, it comes in there and snakes behind and under. So for me, since my computer's flipped around, the port isn't there anymore. Actually, it's, instead of being on the bottom right, it's actually on the top left now. Now, if I'm to mount the cable as kind of done in the instructions, it comes out here. There's actually not enough room for it to come around and plug in there. You may think that there's enough room because the cable would actually reach, but it wouldn't be able to reach without any bunching in the cable runner. And then what that would mean that if the machine's going to like the furthest part it can, which would be like around here, so it kind of extends out fully, the cable won't be able to reach there, and you might cause some damage to your machine. So what I ended up having to do was, okay, well, it can't reach across the other side. Let me, instead of mounting it on the right side, I'll mount it on the left side. So that's what I did. I mounted it on this side going across to here. And now I didn't want it to go across there and then kind of cross over with that, so I did the same with the other one. So instead of it kind of coming in from the pin assembly on the right and then on the right again, mine goes on the left and then on the left again. And that can be seen in this photo over here. So it kind of comes from the pin assembly on the left and then across and then plugs in at the top over there. So yeah, that's all, that pretty much solved all my issues. And yeah, I think that's pretty much it in terms of the assembly and the problems that I encountered along the way. I know that this has been a bit of a speed run of walkthrough, but hopefully this has provided a good overview of what you need to do in order to assemble this. So whether you're just starting out, hopefully you kind of see the direction that you're going, and maybe if you're encountering some problems that I was also encountering, maybe this will kind of help you. And yeah, in terms of the software for this machine, since it is a budget machine, the software support isn't fantastic. The EleksCAM software is good to kind of start out, but it is very rudimentary. So it has got a lot of bugs in it. It's pretty base level. I've managed to kind of do text with it. So kind of write out text in different fonts, and also do a couple of the example images that they have. So the way that you do that is you plug the power into there. I'll get a image where this is the right way up. So yeah, the power goes into there, USB-C cable into there, which the computer kind of sends information through. So yeah, the EleksCAM software is good for starting out, but it isn't great. And now if you want to get into kind of plotter art and stuff like that, you might want to look into other solutions besides EleksCAM. I know that Inkscape might be, I'm still kind of working on the software side of things on my end, so I haven't got all the answers, but I know that Inkscape is a good software. For the more expensive EleksDraw, which I think is more like $700 or whatever, there is a plugin for Inkscape that interfaces with EleksDraw, and what that would do is it would take the vector images or the PNG images and convert it to G-code, and G-code is what the kind of instructions that the plotter can understand to move and actually draw what we want. So yeah, in terms of solutions for the EleksDraw, I think there are multiple kind of avenues you can go down, one of which is writing your own G-code. So if you're into programming or something like that, you can probably write a Python script that takes an image or and then uses some sort of algorithm to determine the kind of pathing that you want to use, and then convert that to G-code, which you can send to your EleksDraw. But yeah, there's a few different options available. But in terms of the hardware side, this is about it. And yeah, if you have any questions, feel free to let me know, post them in the comments below, and I hope this helps.